Hello, algebra students. This is Mr. B. Today we're going to learn about graphing quadratic functions. Those graphs are called parabolas. You've probably seen these in math classes somewhere. Anyway, here's what we're going to start with. F of x equals ax squared plus bx plus c. A lot of people call this standard form. Some people call it general form. We're going to call it a quadratic function. And there's two kinds of graphs that can happen. The parabola might open upward, or the parabola might open downward. And let's look at some of the features of these graphs. The most important is the place that's the minimum or maximum value, this place called the vertex. So I've labeled it V on both of these graphs here. And that vertex is located at an x value of h and a y value of k. And if the parabola opens upward, that vertex is a minimum value. The y value k would be the smallest value that the function has. If the parabola opens downward, then the k is the maximum value of the function. How do you know whether it opens up or down? All you have to do is look at the first coefficient, the coefficient in front of x squared, the leading coefficient. If that a is greater than 0, it opens upward. If it's less than 0, it opens downward. So a negative a, it opens down. Parabolas are symmetric about a vertical line called the axis of symmetry. Both of these graphs have this axis of symmetry. You'll see it here. The equation for that line is very simple. If you knew what the vertex x location was, h, it's x equal h. The axis of symmetry is x equal h. Let's see, what else can we point out? I think that's about it. Now, the way we're going to find the vertex is by using the vertex formula. There's other ways to find it, but we're going to start with the vertex formula. The h value in the vertex, so the vertex is located at h comma k. That's the ordered pair of the point that's the vertex. The h value is negative b over 2a. And then the axis of symmetry will be x equal negative b over 2a, right? Because it has the same x value. The vertex goes, the axis of symmetry goes through the vertex. All right, how do you find the y value? Well, all you have to do is put the h value into the function and get the y value, right? Because that point has to be, this point has to satisfy this equation. So if you put in an x value like h, it's going to tell you what k is. I'll show you in an example. We'll get h, then we'll put it into the function and get the k value, the y coordinate of the vertex. All right. Other important places on these graphs. The y-intercept. I see I didn't label this one. Here's the y-intercept for this graph. It's the place where the graph crosses the y-axis, right? And how do you find that place? Well, at that place, that point, the x value is 0. So if you put x equals 0 into this function, x equals 0, you'll see that the first term and the second term will go away. And the only thing left will be c. So the y-intercept is always c when you have this form for the quadratic function. All right. Sometimes, and not always, the graph will cross the x-axis. And if the graph does cross the x-axis, then you get these points called the x-intercepts. How do you find those? Well, they're located where y is 0. So you set the function, remember the function f of x is y, you set that equal to 0, and you solve. We know how to do that. We either use factoring, if it's factorable over integers, Or we can use the quadratic formula. Okay, let's do an example here. Let's do an example. Let's move this up here. All right, let's start by getting the vertex. All right, so the vertex. We know that h is going to be at negative b over 2a. Let's identify a, b, and c here. A is 1, b is negative 8, and c is 14. All right, so negative b is the opposite of negative 8, and 2 times a, that's 2 times 1. So we're going to get positive 8 over 2, that's 4. All right, to get k, we're going to get the function value at 4. So we're just going to plug 4 into our function. So we're going to get 4 squared minus 8 times 4 plus 14. And I think if you do this, let's see, you get 16 minus 32 plus 14. Well, 16 and 14 add to 30, and minus 32, we're going to get negative 2. So the vertex B is at h comma k, and those are 4 comma 2. And the axis of symmetry, is going to be x equals 4. Why don't we start to draw this thing a little bit, now that we know the vertex? Actually, what we could do is do a little, what I call a thumbnail picture, just to figure out what features we have to find. Okay, so 4 negative 2 is maybe down here somewhere. And so here might be our parabola. We can see immediately that we're going to have some x-intercepts, and we're always going to have a y-intercept. Every parabola has a y-intercept. What is that y-intercept? The y-intercept, we said, was at this value, 14, right? It's at f at 0. F at 0. That's going to be 0 minus 0 plus 14. I said it was the c. It is the c. It's 14. Okay, so this is 14. We already know that. And we know that this is 4. And we know that this is negative 2. We'll draw a careful one in a second. Okay. So we can see that we're going to get some x-intercepts, and they're the last things we really need to get here. So let's find them. The x-intercepts are going to be located where this function is 0. So we're going to have to solve this equation. 0 equals x squared minus 8x plus 14. Now, I'm not really confident that we're going to be able to factor this. I don't think we can find two numbers that add to negative 8 and multiply to 14. Numbers that multiply to 14 are 14 and 1 and 2 and 7. Even if they were both negative, we're not going to get a negative 8 if we add them together. All right, so let's use the quadratic formula. X equals negative b, so I'm expecting you to know how to use the quadratic formula. Negative b is going to be positive 8 because b is negative, plus or minus the square root of b squared, that's negative 8 squared, so that's 64, minus 4 times a is 1 times c is 14, all over 2a, a is 1. All right, so we're going to see that this gives us 8 plus or minus, what is in that square root? I think that's 8. It's 64 minus 56, and that's 8. So this is really a square root of 8 sitting there, and we know that we could simplify that from our knowledge of radicals to 2 times the square root of 2. So this is 8 plus 2 square root of 2 over 2. Okay? And then we see a common factor here. We can simplify this to 4 plus or minus square root of 2. Now, just for graphing purposes, it's nice to write that square root of 2 as a decimal, like 1 decimal place, so you can kind of get an idea where it is. And square root of 2 is about 1.4. And that makes sense, right? They're going to be, this graph is symmetric, so we're going to go to the left from 4, and we're going to go to the right from 4, square root of 2, or about 1.4. And that's where those intercepts are. Okay, let's graph this thing in a more careful way. There we go. So 1, 2, and we got to go up 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whoa, it's way up there. That's 10, 11, 12, 13, 14. All right, so that's 14. There's our y-axis. And here's our x-axis. And 1, 2, 3, 4. I'm trying to find the vertex, which is right here at 4, negative 2. I'll put the numbers in later. I always put them in and then they're in the way. And let's see. We can start to put in our intercepts. The y-intercept is here at 14, and it's going to have a symmetric point. Here's our axis of symmetry. It's going to have a mirror image over on the other side. So where is it going to be? Well, from the axis of symmetry, we went to the left 4 units to get to the y-axis. We have to go to the right 1, 2, 3, 4, and that'll give us the location of another point, which is always nice to get. That's right here. It's the symmetry point for the y-intercept. Okay, now let's get those x-intercepts in there. This is 4, and then we have to go down 1.4, so maybe that's about there, not quite 1.5. The other one's maybe about there. So now we can sketch in our parabola. This is a little scary since it's so far here. Let's see. Whoop, I even missed it there. Okay, so to come through, I'm going to start over. That's awful. No good. Luckily, I can erase it by just one little click. I'm going to be careful here. I'm going to come down through there. I'm trying to get through that point, and then it's going to curve around. Oh, boy. Mr. B's hand is not steady today. Okay, I'm good on the right side. There, well, okay. You get the idea. Maybe I'll clean this up with a little eraser here. Let's take care of that. Okay. So you'll have to give me a little slack today. So how far is this? This was square root of 2, this distance there to there, right? And this distance here is also square root of 2. Maybe we'll start to put in some numbers here. This is 8. This is 4. Negative 2. I'll put in the origin. And we have just about everything else here. If we wanted to, we could state what these points are. This point is 4 plus square root of 2. And this one right here is 4 minus square root of 2. All right, what have I forgotten? Have I forgotten anything? I think I see everything there. And we see that our vertex is a minimum. It's a minimum value. I guess we could state the domain and range if we wanted to. The domain is going to be negative infinity to infinity. Every parabola, every quadratic function, domain is negative infinity to infinity. And the range, what's the smallest y we see? The smallest y we see is negative 2, including negative 2, right? That's where the vertex is. and it goes to infinity. So these are nice things to get too. All right. Hope you got something out of this video. We'll see you in another one soon, I'm sure.